Hey guys, my name is Scott, and today we're going to be continuing our data structure series, and we're going to be looking at circular linked list. Now, if you don't know what singly linked or doubly linked lists are, and you're not familiar with the linked list family whatsoever, what I really advise you to do is to go look at the previous videos, or to find a source you're really comfortable with, and to look up what singly linked and doubly linked lists are, because this video assumes you have some pre-knowledge of what those data structures do. All right, with that in mind, let's continue. So a circular linked list follows by the same principles as a doubly linked list, in that every node has a pointer to the previous and the following node. The only difference is that in a circular linked list, the tail node actually has a pointer that points to the head node of the list. So it actually creates a circle for itself and when it comes to references. All right, and so what we're going to be doing today is I've already defined this. I've already defined a pseudo class, and basically what we're going to be doing is we're going to be doing the same thing we did in the last couple of videos, and that we're just going to define a method that allows us to dynamically add to a list every single time this method is called. All right, so if you follow with the last two videos, this does not seem strange to you at all. So just copy or type this out however you wanted to do it, and let's get started. Okay, so I've already created a node at the top of the function body. The only difference is that in this next property, I've put this.head. That's because we always want the tail node of the list to always point to the head of the list. So I'll just fill the next property with this.head. Now, the first thing we're going to do is say, hey, if this.head is null, if this.head is undefined, if this.head is false, then we're going to assign this.head node, and then we're just going to return node. Awesome, and we're only returning node for confirmation, as you guys know. Now, right after that, we're going to type this, which I'm going to explain it just here in just a second. So don't be scared if you feel like it doesn't make any sense to you. We're going to do this.head.next. If this.head.next is null, if this.head.next is false, undefined, then we're going to say node.previous equals this.head, and then this.head.next equals node. And then after that, you're going to return node. Okay. Now, the first time this is ran, or the first time the method is called, we're just assigning this.head a node, and then we'll return the node. But you'll notice that this.head points to itself at this moment. So you may be wondering why on line 18 we have another if statement that checks to see if this.head.next actually has a value. Well, the reason being is because yes, we're assigning this.head node, but at this point whenever we're actually creating our node object, this.head is still null. It only gets assigned a value right here on line 14. So because it gets assigned a value on line 14, and at this point it's null, whenever we return our node, we'll see that that actual next property is going to be null. So we do a double check right here. We're like, hey, if this.head.next equals null, then we're going to assign node.previous this.head, and then we're going to assign this.head.next the new node, which is going to have another value, and then we're just going to return the node as confirmation. All right. Then right after that, we're going to create two variables. We're going to create one called this.head and another called current, which is this.head.next. All right. And then after that, we're going to create a while loop, and then we're going to say current.next and current.previous. And it's going to say previous equals current, current equals current.next. Now, the reason why we're doing this is because every single node that we're on, besides the head, is going to have a previous and a next value, right? Right. Well, that's why we assign current this.head.next, because we know this.head, its previous pointer is always going to be null. Its next pointer is always going to have a value. And so in order to travel through our list, we have to pass in the reference to this.heads.next object. We have to pass that reference into our current variable in order to actually travel through our list. And then as we're traveling, we say while current.next has a value and while current.previous has a value, we're going to assign previous, which is the previous node that we were on. We're going to assign that current. So in the first iteration of this, previous, if it was this.head, becomes this.head.next. And then current is going to become this.head.next.next. You see what's happening right there. The only trickery happens is whenever we get to the tail of the list, because when we get to the tail of the list has a next pointer and it also has a previous pointer. So what's going to happen is current is going to then be assigned head. And whenever it gets assigned head, we know that its current.previous value is going to be null. And we know that previous is then going to be the tail of the list because it was the last node within the list. It was the node before we got to our head node. After that, we're going to assign node.previous. We're going to assign a previous, which will be the tail of the list, and then we're going to assign previous.next is going to be node. So we're going to actually reassign the tail of the list next properties value. All right, and then after that, we're just going to return node for confirmation. Okay, and so everything looks good on this end. We're just going to see this in action now. Keyboard shortcuts are amazing, guys. All right, so we've entered in. It's good. You just press Control L to clear out things, and then we're going to say var list equals new circling list. All right, then we're going to say list.add 1. Right, and as we expected, next equals null, previous equals null. And we're going to say list.add 2. Awesome. We're going to do list.add 3. We're going to do list.add 4. All right, and then after that, we'll do a list.add last. Why not? Last. Okay, and then we're just going to get the state of our list. Just type it in list. All right, so we have a circularly linked list right here. Go on, you can do it. You're being slow. All right, awesome. So you have the head, and it has a next. This next property has a value of an object. This previous property has a value of null, and its next property's object, or that next node, has a value of 2. Its previous points back to the head. I'm sorry. Its previous points back to the head, and its next points to the next node in the list, and then that next node in the list points back. Its next points to 4. The same thing, it points back. Its next points to the last, and the last points to head, and its previous. Why did I do that? Its previous points to 4. Anyways, okay, so this has been Circular Linked List. I hope you guys have enjoyed it. I hope it was really informative, and you guys have a great day. I've put the code inside my GitHub, and I put a link to my GitHub inside the description of this video. So yeah, check it out. There's going to be a little bit of a challenge inside the code. So if you want to learn how to manipulate circular linked lists, just go and do the assignment. All right, you guys have a great day.